The purpose of this video is to explain the six-step problem-solving approach that is expected that all the students use throughout the course. So the six-step problem-solving approach consists in the following. If you go to the course syllabus, which was provided at the beginning of the classes, so your problem solution, the correctness of that is only 75%, but 25% will consist in 6 steps. This is a typical 6 steps that we use in the industry. So let's consider this. The first thing is we want to solve the problem. We want the problem description. We want to read the problem carefully, do a sketch if we need to do a sketch, give all the variables. For an example, let's use this case. This is one of the examples that we covered in class. So let's suppose we want to just solve this. So in this particular problem, when you solve it, what you want to give the reader, whoever's going to read the solution of your answers, is what do I have? Well, you can do another schematic of the drawing. You could redraw this again. And then you could also say, if for this problem B is equal to 5 millimeters, I know that L is equal to 1 meters. I know that A is equal to 25 millimeters. This is given in the problem, by the way. All this information is known, and then you can say, this is information that we want to find. Vy, Vz. So we want to know what these are, what the moments are. We want to find all the moments, Myy, Mzz. And you would like to know what the value of those moments are. Okay, so you're just basically telling the reader, this is the problem I have in hand. The second problem, it says, what is the problem objective? What is specifically are you asking, what you asked for? So, okay, so let's suppose in this problem. In this particular problem, we can make a couple of assumptions. First of all, we can assume it's a constant cross-section. So you can assume the section is constant. You can also assume that these are assumptions, by the way. It's a constant cross-section, constant material, and the consequences of this is no additional section cuts, no discontinuities, so no additional section cuts. Okay, so then if you had any other assumptions you would like to make, you can also say Newton's second law applies. So you're saying load is slowly varying or constant, and say summation of forces is 0, summations of moment is equal to 0. Okay, so those are some assumptions you can make. Then, based on the information, give any theories, equations that you probably need to solve this problem. So you could say, I'm going to solve this. So what you could do is you can say, oh, these are the equations, and they come from Goyal notes, page 329, 330. And that's one possibility you could do. You could just go ahead and add that. Or you can write these equations, and those are the equations that you mainly are going to use. The next part is to solve the problem. In this problem, you do all your section cuts, go in detail, solve the whole thing, find what your equations look like. Okay? The last step is you want to show your results. In showing your results, you have to give all your plots. You can use MATLAB for that. You're not required to develop a new MATLAB code, just use the one that's given. And then you have an XX, VY, VZ, the same thing for MXX, MY, MZ. So that's your solution. For number 6, you want to discuss your answers, and you want to uh, discuss the answers you have. So the whole purpose of this is basically to find a critical location. So you can, and we know that this is moment driven, right? The problem is moment driven. There's rarely axial loads or shear driven. So your critical location will be the location where your moments are maximum. In this particular case, it's crystal clear that all your moments are maximum right here at x equal to 0. Okay, so they're right here. So you can say x equal to 0 plus is the critical location in x. Okay, and at that location, your moments mxx will be minus 25 pound-inches. MYY would be minus 1,000 pound. Oops, sorry. Inches, pound, inches, pound. MZZ would be minus 50 inches, pound. So this will be the explanation of that, and you can explain why each one of these were actually critical or not. Okay, so this basically summarizes the 6-step process that you're asked and you're required to do in each one of your homeworks.